All right, so here we're going to talk about slope and rate of change. These things are very similar to one another. Rate of change is more something you're kind of be asked, or it'll be phrased that way when you're talking more about word problems. But let's go ahead and let's get into what the slope formula is. Okay, obviously you need to know the slope formula pretty darn well because it's going to be something you're going to use a lot, not only in this lecture, but in so many future problems, especially when it comes time to the EOC in April. Right? So when you're given 2 points, or when you have 2 points, you can find the slope between them with this slope formula. M is just the variable that represents slope. So when you write, when someone writes m equals, they're just really saying that slope equals. Now x1, y1, x2, y2, these are ordered pairs. So x1, y1 is just an ordered pair from 1 point, and x2, y2 is an ordered pair from the second point. So you can consider this to be the first point, this can be the second point. This is how you'd plug them in. So you would take your y2 value and subtract your y1 value, take your x2 value and subtract your x1 value. Okay, so let's see that in practice. Okay, so let's just do a couple of these. They're all pretty much the same thing, but it's just the point of doing so many is just to get you kind of used to where the numbers go in the formula. So let's just say this is point 1, this is point 2. It does not matter which one you call point 1, which one point 2, as long as you plug them in properly into the formula. All right, so that would make, remember our formula is y2 minus y1, x2 minus x1. So if we call that point 1, that would be x1 and y1. This would be x2 and y2. So filling in all the numbers, this would be 12 minus 4 over 5 minus 3, which gives us 8 over 2, which simplifies to the number 4. All right, and for number B, or for the second question, B here, let's just change it up. Why not? Let's call that point 1. Let's call that point 2, just to show you that it really wouldn't make a difference. This would be x2, y2, x1, y1. So remember your formula, but plug it in. In this case, it would be y2, which is 6, minus y1, which is 2, and x2, which is negative 1, minus x1, which is 3. So this one would be 4 over negative 4, which simplifies to negative 1. All right, so let's just do one more just quickly. I want to show you about double negatives. So let's say this one would be, this is point 1 and this is point 2. This would be 3 minus negative 7. So be careful of double negatives like that, and negative 1 minus 2. The top actually becomes 3 plus 7, which is 10. And the bottom becomes negative 1 minus 2, which is negative 3. So it's negative 10 thirds. All right, I'm just going to skip ahead a little bit here. You can see the last two. I think you get the general idea. Notice that on the last one, or the last two, the d is 0 divided by negative 5, and 0 divided by anything is 0. In the last one, the denominator is 0. And when that happens, it's undefined, because you can never divide by 0. So you might already know some of this. Remember your y-intercept, your slope-intercept form of an equation. If you have a line and as an equation, mx plus b, remember that the m value is your slope value, your b value is your y-intercept on your graph. So if I want to find the slope for A, recognize that this is mx plus b right here. 4 is our slope, and negative 3 is my y-intercept. For B, notice I've got, this is my m value, so that's my slope, which is negative 1. There is no plus b, so my y-intercept is 0, because it's technically plus 0. Part C, you would divide by 3 first, because it's not in slope-intercept form. Then you would see that this is your slope. 5 over 3, and that this one is your y-intercept. That equals 3, by the way. So your y-intercept would be at 3. And for y equals 8, this is your y-intercept. It doesn't have a slope. Well, it does have a slope, but think of this more like it's y equals 0x plus 8, right? 0 being the slope, so it's a flat line. That's why the x is gone, because 0 times x would just become 0, so you wouldn't see it. You would just see plus 8. So 0 would be the slope, 8 would be the intercept. Okay. Important being able to write the equation of the line, give it some information. So if we know that the slope is -2 and the y-intercept is -4, we know our equation is supposed to be in slope-intercept form. I already know the 2 pieces of information to put into this equation. So I know that y equals, my slope, m, is -2, so it would be -2x. My y-intercept is -4, so I know to plug in -4. So I'm just filling in for m and b. Part B is pretty much the same. Slope and y-intercept is given to us, so just plug it in. Plug 1 in for m, plug 7 in for b. We have 1x plus 7, which you could just write as x plus 7. Part C being a little bit trickier. Okay, so we know the slope. We know that's the m value, so we know y equals 2x, but we don't know what b is, because this is not the y-intercept. We don't know what b is yet. However, we can use the point that we're given to our advantage, because in this point is an x value and a y value. So we can use this x value and this y value in our equation here, and then figure out what b is. So given this information, y is 2, so let's change y to 2. Let's use it temporarily to help us find b. 2 is my slope, remember, and then x is also 2, so we're going to plug in this 2 for x. So remember, this is my y, this is my x, that's my m. Everything's just being plugged in right now. All in name of trying to figure out what b is. So if we solve this equation, we'll have 2 equals 4 plus b. We subtract 4, and we can get what the b value is. B is going to be equal to -2. So now I know that b is -2. I can finish my equation. My equation will be y equals 2x minus 2. So it's a kind of a backroads way of finding out b, but it's enough information that if you use it correctly, you can ultimately get your goal of writing that equation. Okay. This one a little bit, well, D is the same, E is a little bit fancier. So for D, again, we know the slope already, so we already know half of the information. We know m, but just like the last problem, we do not know the y-intercept. We're just given a point. We're given x and y information instead. But remember, we can use this information to help us figure out what that b value is. So mx plus b, this is my goal. I already know m. I know m is -4. But I don't know b. However, I can use this x and I can use this y in my equation to help me find b. So y is 5, x is 1, and then so I'm going to plug them in, and now the only thing to solve for is b. So this would be 5 equals -4 times 1 is -4 plus b. So if you add 4 to both sides, we'll get b equal to 9. So now I know my b value. Let's put it in here. So my equation would be y equals -4x plus 9. Now part E is trickier because you have to do, go through even more back roads, but you can still get your answer. So it doesn't tell me the slope, and it doesn't tell me the y-intercept. It just gives me 2 points. But remember, if you have 2 points, you can use your slope formula to find out what the slope is. So let's do that. Let's use these 2 points to find out what the slope is. So let's call this point 1. We'll call that point 2. So this would be 4 minus 7 over 0 minus -3. So this would be 4 minus 7 is -3. and 0 plus 3 is 3. So my slope is -1. So now I know what my m value is. So using this formula, I know m is equal to -1. So I know the equation y equals -1x plus b. But again, I don't know what b is. However, I've got just 2 points I can choose from here that have x and y's in them. It doesn't matter which one you pick. It's the same as using 1, 5 in the last problem. Remember when we plugged in 1 and 5 because we had it x and y? Well, here we have 2 options. We can either plug in -3 and 7 or 0 and 4. I'm going to plug in 0 and 4 because 0 and 4 just look like easier numbers to use. So let's use 4 for y. -1's my slope. X is going to be 0. And then plus b. So when I work this out, -1 times 0 is 0. So that means b is equal to 4. So now I found m. I found b. So I know my equation. Y equals -1x plus 4. Okay. Now we're going to talk about rate of change. Rate of change, it's the same thing as slope, but it's more of a applicable type of thing. Or I don't know how I mean, it's kind of the same name for the same thing, or a different name for the same thing. So here we're given a function, right? F of x equals 5x squared. We're asked to find the average rate of change over this interval from 2 to 4. Now, when it says interval, this is referencing these as x values. It's saying that x is 2 and x is 4. So we're going to try to find out what the slope is between x being 2 and x being 4. Now, what we need, obviously, to solve this, find the rate of change, use our slope formula, is we need 2 points. Now, what we're going to do is we're going to use these x values to help us find out what those points are. If we know we're looking at, we want to know where the y value is when x is 2, then what we're going to do is we're going to plug in 2 to this function, and we'll get its corresponding y value. That way we'll have 1 point, and then we'll plug in 4 into this function. We'll get its corresponding y value, and we'll have our second point. Once we have our 2 points, we'll use our slope formula and find our slope, i.e. our rate of change. So let's try that. 5x squared. But remember, we're going to plug in 2. Let's plug in 2 first. So that would be 5 times 2 squared. Remember, exponents come before multiplying, so you do 2 squared first. 2 squared is 4. So this would be 5 times 4, which is 20. So when you plug in 2 for x, you get an output of 20. So we have the point 2, 20. Now we're going to plug in the 4 to see what its output is. So if you have 5x squared, we plug in 4 for x. Same as before, do the exponent first. 4 squared. 4 squared is 16. And 5 times 16 is, I believe, 80. You might use a calculator to figure that out, but I'm pretty sure it's 80. So when you plug in 4, you get an output of 80. So we have the point 4, 80. So remember, these were just x values. Basically, you knew that 2 something was a point, and you knew 4 something was a point. But by plugging in these x values, you figured out what their outputs were. Now you've got these 2 points. So use your slope formula, call that point 1, call this point 2, and find your rate of change. So this would be, using the slope formula, 80 minus 20 over 4 minus 2, which makes 60 over 2, which 60 divided by 2 is 30. So my rate of change, my average rate of change is 30. All right. What I'm going to do is I'll stop here this example, but I'm going to put the next problem up just to show it to you. It works the same way as the last problem by, you got to plug in these values here for x. If you want to pause the screen and try that on your own, that's good. In about 5 seconds here, I'll just show you the answer, okay? And you can check to see if you were right, okay? But to save time, I'll let you guys kind of finish that up. All right? So, with all that being said, I hope you found this helpful, and I will see you in the next one. Bye-bye.